Right now, the force that sculpts galaxies, crushes stars into black holes, and anchors your very existence to this planet is battling something impossible, a flimsy, pocket-sized magnet. Think about it. This tiny piece of metal, no bigger than your thumb, can snatch a paperclip from the colossal gravitational grip of an entire Earth. An entire planet's worth of mass, its immense pull, is effortlessly defied by a trinket you can hold in your hand. This isn't just strange, it's a cosmic obscenity, a fundamental imbalance screaming at us from the heart of reality. Why is gravity, the universe's master builder, so unbelievably, ridiculously weak? Where is its true terrifying strength? You just witnessed the universe's most profound paradox in action. A refrigerator magnet laughs in the face of an entire planet. That isn't just a quirky parlor trick. It's a cosmic alarm bell screaming at physicists for nearly a century. Gravity, the force that binds stars, sculpts galaxies, and anchors your very existence to this planet, is the weakest, most baffling fundamental force we know. It's the gentle giant, but at the quantum scale, it's a pathetic whisper. Think about the forces that truly run the cosmos. You've got the strong nuclear force, the cosmic superglue that clamps atomic nuclei together. Without its unimaginable grip, every atom in your body, every star, every galaxy would instantly explode into a chaotic mess of protons and neutrons. It's the most powerful force, binding quarks within protons with an iron fist. Then there's the electromagnetic force, the invisible architect of chemistry, binding electrons to atoms, igniting stars, and powering every circuit in your life. It shapes light, generates magnetism, and orchestrates the dance of all charged particles. And finally, the weak nuclear force, the silent instigator of radioactive decay, constantly transforming matter and fueling the sun's relentless furnace. Each of these forces wields titanic power at the subatomic scale. But then there's gravity. While the strong force commands nuclear reactions with an authority you can barely fathom, and electromagnetism orchestrates the very fabric of matter, gravity just sits there, barely registering. Electromagnetism, for instance, is an incomprehensible trillion times stronger than gravity. Let that sink in for a moment. If you stood two electrons a hair's breadth apart, their electromagnetic repulsion would hurl them away from each other with a violence that would rip space itself. Their gravitational attraction, by comparison, would be so minuscule it might as well not exist. It's like comparing the roar of a supernova to the whisper of a single dust mote falling on the moon. It's not just a small difference, it's an astronomical chasm of power. This staggering disparity, this almost comical feebleness of gravity when you try to apply it to the subatomic world, is what physicists call the hierarchy problem. It's the ultimate cosmic head-scratcher. Our most elegant theories of physics, especially quantum mechanics, predict that all fundamental forces should have comparable strengths at incredibly high energies, the kind of energies present at the Big Bang, the very dawn of time. But gravity stubbornly refuses to play along. It's an outcast, a cosmic anomaly that defies every expectation. It's as if the universe built a magnificent, intricate machine, then used a single thread of cotton to hold up the entire foundation. This isn't just an oddity, it's a gaping, terrifying hole in our fundamental understanding of reality. It's the defiant, unyielding mystery that has brought some of our most brilliant minds to their knees, hinting at a hidden truth far stranger than we can currently grasp. This imbalance isn't a bug in the cosmic code. It's a feature, a cosmic breadcrumb leading us to something profoundly unsettling about the very nature of space, time, and existence itself. It suggests that what we perceive as reality might just be a small, incomplete slice of a much larger, more complex cosmic pie. And this pie might be hiding gravity's true power. For nearly a century, the greatest minds in physics have chased a ghost, a single, elegant theory that could unify all the fundamental forces of the universe. Albert Einstein, the architect of space-time itself, spent the last 30 years of his life in a relentless, ultimately fruitless pursuit of this theory of everything. He dreamed of a grand symphony where every cosmic note, from the smallest quantum flicker to the largest galactic ballet, resonated in perfect harmony. The dream, in part, did come true. Physics forged the Standard Model, a triumph of human intellect that brilliantly stitches together the electromagnetic, strong, and weak nuclear forces. It explains with exquisite precision how light behaves, how atoms hold together, and how the sun burns. It's a glittering crown jewel of science, predicting new particles, new interactions, and unlocking the very secrets of matter. But gravity remained an outcast, a rogue agent. It refuses to be tamed by the elegant equations of the Standard Model. It's the discordant note in the cosmic symphony, the one instrument that won't play along. The hierarchy problem isn't just an anomaly. It's the towering, insurmountable wall blocking the path to true cosmic unity. Our quantum theories, which describe the universe at its most fundamental microscopic level, predict that gravity should be just as powerful as the other forces at high energies. But it simply isn't. It's a cosmic whisper where there should be a roar. This isn't merely an academic inconvenience. It's a full-blown cosmic crisis. Our two most successful, most mind-bending theories of reality, general relativity, Einstein's masterpiece describing the elegant curving fabric of space-time and the immense pull of gravity, and quantum mechanics, the bizarre probabilistic world of subatomic particles where reality blurs into possibility. They clash. They scream fundamentally different truths about the universe. General relativity paints a smooth, continuous cosmos. Quantum mechanics insists on a grainy, jittery, uncertain reality. Try to force them together, especially at the extreme energies of the Big Bang, and their equations shatter. They produce infinities. Nonsense. It's like trying to describe a calm, deep ocean with the language of a constantly frothing, boiling pot. They just don't mesh. Physicists are locked in a desperate struggle, trying to reconcile these titans. They are haunted by gravity's inexplicable weakness, knowing it holds the key to the universe's deepest secrets. This profound disconnect, this cosmic discord, demands a radical, almost heretical solution. It demands something utterly beyond our current 3 dimensions, something that redefines the very stage upon which the cosmic drama unfolds. If this mind-bending struggle between the universe's fundamental forces has you gripped, if you're ready to unravel the deepest mysteries hidden in plain sight, then smash that like button and subscribe, because the answers are out there, and they are stranger than you can possibly imagine. What if gravity isn't actually weak? What if its colossal power is simply hiding from us? This isn't some fever dream. It's a radical, desperate, yet utterly compelling hypothesis emerging from the deepest reaches of theoretical physics. It's the idea that our entire universe, every star, every galaxy, every atom in your body, is merely a thin, 3-dimensional membrane, a brain, floating within a much larger, unseen, higher dimensional realm. This colossal, unseen space is what physicists call the bulk. Imagine a garden hose seen from a distance. It looks like a one-dimensional line, but get up close and you discover it has a hidden, curled up, circular dimension wrapped around its length. Or picture a sheet of paper. From far away, it seems 2-dimensional, but a tiny ant crawling on its surface can move not only forward and backward, but also up and down through the paper's thickness. Our universe, this theory suggests, is like that sheet of paper or that garden hose, but with even more dimensions curled up so tightly, so impossibly small, that we can't perceive them. They exist at every single point in space, interwoven with our familiar length, width, and height. According to monostring theory, the leading candidate for a theory of everything, the fundamental building blocks of reality aren't tiny point-like particles. Instead, they're unimaginably small, vibrating loops or segments of energy called strings. Think of them as cosmic rubber bands, each vibrating in a different pattern, and each pattern giving rise to a different particle. An electron is one vibration, a photon another. But here's the crucial, mind-bending part. These strings don't just vibrate in our 3 spatial dimensions. They vibrate across all 10 or 11 dimensions that string theory predicts. Now, here's where gravity's weakness finds its stunning explanation. The particles that make up you, me, and everything we see, electrons, quarks, photons, these are all closed strings, or open strings, that are stuck to our 3D brain. They can't escape. They are trapped, confined to our universe, unable to venture into the extra dimensions. That's why the electromagnetic, strong and weak nuclear forces operate exclusively within our 3 dimensions. Wielding their immense power, they are bound to our cosmic membrane. But gravity is different. According to this hypothesis, the particle that mediates gravity, the hypothetical graviton, is a special kind of string. It's an open string, or a closed loop, that is not stuck to our brain. It is free. It can propagate. It can leak. It can slip away. Gravitons, unlike photons or electrons, can simply drift off our 3D brain and disappear into the vast, unseen higher dimensions of the bulk. Imagine a giant cosmic sponge. Our universe is just the surface, and gravity's true power is like water soaking into the hidden depths of the sponge. From our perspective, trapped on the surface, the water seems to vanish, its strength diluted. The gravitons are constantly escaping, leaking their immense power into these extra hidden dimensions. This means gravity isn't inherently weak, it's just spread out. Most of its power, its true terrifying strength, is lost to us, dissipating into the higher dimensional bulk. What we feel as gravity's feeble tug is just the tiny fraction of its total power that remains confined to our brain. It's like hearing a whisper from a conversation happening in another room. The conversation is loud, but you only catch a fraction of the sound. This radical idea transforms the hierarchy problem from a bewildering paradox into a profound clue. Gravity is weak in our universe because it's playing on a much larger, multi-dimensional stage. It's the only force with the cosmic passport to travel between dimensions. This hypothesis doesn't just explain gravity's weakness, it shatters our entire perception of reality. It suggests that our universe is not some isolated, self-contained entity, but merely a single, thin slice of a far grander, infinitely more complex cosmic onion. A universe not just surrounded by empty space, but by other dimensions, teeming with unseen possibilities, and potentially other brains, other universes, existing just a hair's breadth away, completely invisible to us. If gravity truly leaks into extra dimensions, then the universe we inhabit isn't just a 3D stage. It's a permeable membrane, constantly interacting with unseen realms. This isn't just a theoretical curiosity. It demands observable consequences. If gravitons are constantly slipping away, there must be a way to detect their escape, to find the shadows of the bulk chaos cast upon our own reality. The most direct way to test this mind-bending hypothesis involves probing gravity at incredibly tiny distances. In our familiar 3 dimensions, gravity follows a precise rule. Its strength decreases with the square of the distance between 2 objects, the famous inverse square law. But if extra dimensions exist and gravity can leak into them, this rule might subtly break down at very short ranges, distances smaller than the width of a human hair. Think of it like this. If you're pulling a heavy box across a large open floor, the force you exert is spread out, but if the box suddenly encounters a small hidden hole, some of your pulling force might leak into that hole, making the box feel lighter, or changing how it responds to your pull. Similarly, if gravity is leaking into extra dimensions, its force might become disproportionately stronger at extremely close proximity, because at those scales, the gravitons haven't had as much room to leak away. Experiments are currently underway using incredibly sensitive instruments to measure gravity's pull at sub-millimeter scales. Looking for these minute deviations from the expected inverse square law, they're searching for the gravitational drip into the bulk. The implications are breathtaking. If these experiments detect such a deviation, it wouldn't just confirm extra dimensions, it would fundamentally rewrite our cosmic address. We wouldn't be living in an isolated island universe, but on a brain world, a mere surface in a much larger multi-dimensional ocean. This means other brains, other universes, could be astonishingly close to us, perhaps separated by only a fraction of a millimeter in a higher dimension. They would be completely invisible, utterly unreachable, yet existing right next to us. Imagine parallel universes not light years away, but literally a hair's breadth from your nose, existing in a dimension you cannot perceive. Their stars, their planets, their civilizations, if they exist, could be so close you could almost touch them. yet separated by an impenetrable, higher dimensional barrier. It's like two sheets of paper stacked on top of each other. The ants on one sheet are incredibly close to the ants on the other, but they can't see or interact directly. The only force that could potentially bridge that minuscule gap, the only whisper that might pass between these adjacent realities, is gravity itself. This vision evokes a profound sense of existential dread. And our our universe, vast as it seems, might be nothing more than a thin film, a delicate bubble in an infinite cosmic foam. The very stability of our reality could depend on the unseen dynamics of these hidden dimensions. What if our brain brushes against another? What if something from the bulk, a cosmic leviathan, were to ripple through the higher dimensions, causing our membrane to flex and distort, subtly altering the laws of physics themselves? The search for these shadows of the bulk is one of the most exciting frontiers in physics. It's a quest to peel back the layers of reality, to discover if gravity's weakness is not a flaw, but a profound invitation to a universe far grander, far more interconnected, and far more terrifyingly vast than we ever dared to imagine. It's the ultimate cosmic secret, hinting that we are not alone, not just in terms of life, but in terms of entire realities, lurking just beyond our perception, forever influencing our cosmic fate. We began by marveling at gravity's baffling weakness, a cosmic anomaly that allows a tiny magnet to defy an entire planet. But what we've discovered is that this weakness isn't a flaw in the universe's design. It's a cosmic breadcrumb, a profound clue to a reality far more expansive and intricate than our senses can grasp. Gravity, the theory suggests, isn't weak at all. Its true titanic power is simply leaking, dissipating into extra hidden dimensions that permeate every point in space, dimensions we are trapped within but cannot perceive. Our universe, this majestic tapestry of stars and galaxies, is not a standalone cosmos, but a thin three-dimensional membrane, a brain floating in a higher dimensional bulk. Gravity, the ultimate cosmic nomad, is the only fundamental force free to wander these unseen realms, its strength diluted in our perception as it bleeds into the unseen. This isn't just an explanation for a scientific puzzle, it's a shattering of our cosmic solitude. It means we might be living in intimate proximity to other brain universes, separated by a whisper of a millimeter in a dimension we cannot fathom. This revelation transforms our understanding of existence itself. We are not merely inhabitants of a vast empty void, but dwellers on a cosmic film, part of a multi-layered reality, where unseen forces and potentially other universes exist just beyond our reach. It evokes a primal awe, contemplating the sheer scale of what lies hidden, and a touch of existential dread, realizing how little we truly comprehend about the fabric of our own existence. Gravity's apparent feebleness is, in fact, its profound secret, a key unlocking the door to a universe teeming with unseen dimensions and infinite possibilities. Tell me what you liked or disliked about this video. What do you think could be changed to make it better? I read every comment and will respond to every suggestion.